Hello, and welcome to the webinar for the newest release of GeoStudio 8.4. My name is Branden Griffin. I'm here with my colleague, Jeya Iyadural. We're both engineers on the GeoStudio team, and we're excited to take you on a tour of what is new and improved with GeoStudio 8.4. Before we dive in, let me take an opportunity to introduce Disty for those watching who may be unfamiliar. We've been around for just over 30 years now, having been established in 1994. So we have well over 20 years of experience in HMI and UI solutions, simulation, embedded, and safety critical. We are an ISO 9001 small business engineering company with a heavy focus on program management and process-driven workflows. Over 700 companies worldwide are using our software, and content built with our software is in over 20 aircraft and spacecraft platforms, as well as over 20 million commercial cars on the road. To give you an idea of how widely we're used, here are just a few of our customers in industries ranging from aerospace and defense to automotive, outer space, medical, trains, agriculture, and more. GeoStudio is used widely in production of both embedded and safety critical embedded applications. For example, at Hyundai Mobis, GeoStudio is used in a wide variety of different HUDs, clusters, and IVIs. Jaguar Land Rover standardized on GeoStudio for 9 years for the in-vehicle infotainment across all of their vehicles. On the safety critical side, we are used in a variety of aircraft, including the simulators for those aircraft. Furthermore, we collaborate regularly with our partners. No production system is built in isolation. So we partner across disciplines, including OS and RTOS, hardware, graphics drivers, and user space software. Here displayed are some of our major partners over the years. One key benefit of GeoStudio that I'd like to highlight here is that GeoStudio is actually hardware and operating system agnostic. As long as the target system has OpenGL support, GeoStudio built applications are capable of running on that target. Now let's jump into GeoStudio 8.4. With GeoStudio 8.4, we're providing multiple new features in addition to a long list of improvements and bug fixes. The major new features we're going to be covering in this webinar include the addition of cybersecurity testing and reports, an automatic polygon optimizer package, out-of-the-box experience enhancements, and cross-platform video integration. The first feature new to GeoStudio 8.4 that we're going to talk about is cybersecurity testing and reports. And as we're going through this presentation, if you have any questions, please leave them in the Q&A section, and we'll have some time at the end to answer all the questions. So, to provide some context for why cybersecurity is a big new focus for us, we can look to Executive Order 14028, which was signed back in 2021. This executive order is focused on improving the nation's cybersecurity by ensuring software supply chain integrity. And so one of the specific requirements in this executive order is that it establishes baseline security standards for the development of software sold to the government, including requiring developers to maintain greater visibility into their software. So our goal at Disty is to ensure GeoStudio is a secure part of any software toolchain, especially for customers in the aerospace and defense industry. If you want to look at this executive order in more detail, it can be found on the Government General Services Administration website, which is that link that I have listed here. So following that, with GeoStudio 8.4, we've made cybersecurity a large focus. One aspect of that is that SBOM reporting is now available by default for GeoStudio. For those unfamiliar, And SBOM is a software bill of materials and provides a comprehensive inventory of all components, libraries, and dependencies within GeoStudio. In essence, it helps provide a clear understanding of what is included. As an example, the image on this slide is the SBOM that has been generated for the Emscripten Windows package. In the SBOM, we can see details such as the version number, serial number, timestamp metadata, and dependencies, including any external libraries. For instance, we can see one of those libraries components listed here, which is the Google Closure compiler, which is used for Emscripten. In order to generate the SBOMs, Disty partnered with a company called FOSSA, who are experts in this domain. And the specific format for the bill of materials that we are generating is called Cyclone DX, although there are other formats we're capable of generating at customer request. Additionally, for 8.4, we've performed cybersecurity analysis and enacted a security patch to increase the integrity around GeoStudio's third-party dependencies. To access the SBOMs, please visit docs.disty.com, where the complete GeoStudio 8.4 SBOM documentation is available for download. If you want to download the SBOM for a specific package, all of those are listed in the package catalog. I want to note also that the SBOMs are actually included in the packages themselves as well. So, overall, with this new release, GeoStudio is more secure than ever, and we're providing transparency into how that is so. The next feature new to GeoStudio 8.4 that we're going to explore is the automatic polygon optimizer. The automatic polygon optimizer is a new package containing a script that optimizes polygons in your GeoStudio design. The script is designed so that it can run automatically as a pre-gen script, meaning that before the project code is generated, the script will examine textured polygons in the project and perform the optimization. You do have the option of disabling the script if you choose, similar to other pre-gen scripts. Additionally, the script can also be run manually on specific selected objects by clicking this Optimize Selected button on the toolbar. You may be wondering how the script actually works, and I'm going to explain that now. In essence, an algorithm is performed that tessellates textured polygons into a GL trimesh object that more precisely covers the applied texture. The purpose of this is to reduce unnecessary fill drawing, which significantly improves rendering speeds. This is key on embedded systems, which usually have more constrained graphics processing capabilities. One more note to make is that you can customize the pixel buffer size when performing the optimization. This option allows the user to specify to the meshing algorithm how much space they want on the edges of the texture. Because if the edges are pixel tight, the texture might look too sharp on the edges. So this option lets you find the right balance. And so with that, I'm going to switch over to GeoStudio and I'll show you the script in action. So here I have a GeoStudio project, and we can see that there is this Optimize Selected button on the top. And so what I'm going to do is run this optimization on this GeoStudio logo that we have in our design. So if I click on the GeoStudio logo object, I'm in vertices mode. So we can see currently that the vertices make a rectangle quite far from the edges of the actual texture itself. And so to perform this optimization, I can simply click the Optimize Selected button, and we'll leave it at the default pixel edge buffer of 3, and I'll click OK. And so this should take 5 to 10 seconds, and it's going to convert this GL polygon into a GL trimesh, essentially a group of triangle objects. So that's complete. And click on the object. What's also nice about this script is that in the log, it'll output the improvement. So in this case, our optimization is resulting in a 75% improvement in the bytes that are being drawn. And so you can see now, still in vertices mode, we have a bunch more vertices, but they more tightly wrap around the texture itself. And just to show you that a little bit better, what I can do is go and remove the texture from this object. So now we see just the fill area, which is tightly wrapped around the edges of the GeoStudio logo texture. I mentioned that the script can also run as a pre-gen script, and so you'll see that in the deployment settings up here. You can open up the pre-generation scripts section, and we see Polygon Optimizer here. If you have a lot of textured objects in your design, this might take a little bit longer, so I'm not going to show you that for now, but hopefully you find this look at the optimizer helpful. And we're excited for you to try it out yourself. Now switch back to presentation. And next up, we're going to discuss enhancements we've made to the GeoStudio out-of-the-box experience. I'm going to pass the presentation now to Jeya, who is going to guide you through this section. And as we're going through, remember to ask questions in the QA section, and we will answer those at the end.
Yep, thanks, Brandon. Hello, everybody. So just again, if you've got those questions, please drop them in the Q&A section, and Brandon and I will help you get them sorted out at the end of the webinar. So this section covers a bunch of different improvements that we've made to GeoStudio for this release. These are quality of life improvements to the out-of-the-box experience with a focus on embedded systems. Just as a note, I'll refer to embedded systems as ES going forward. The main sections I'll be covering here are deployment, build, and licensing improvements, improvements to our packages and package system, editor and runtime improvements, and improvements to our offline documentation. One of the things we wanted to do with this release is to improve the build and deployment process while using GeoStudio. Here's a small subset of the improvements and bug fixes we've made for deployment specifically. Firstly, support for the Android deployment has been added to Mac and Linux. As of GLS 8.4, all 3 of our supported desktop platforms support the Android deployment. The Raspberry Pi deployment has also been ported to CMake. It now exists as the Raspberry Pi CMake deployment, and it can build 64-bit executables. The deployment still supports 32 executables as well. The embedded CMake deployment has been improved in many ways this release. The build speed has been increased, and the package now contains additional main.cpp and toolchain file examples. We've also got a lot of bug fixes and deployments in this release. The embedded CMake deployment no longer leaves lingering SSH connections open on deploy and run. All one-touch deployments in general time up more quickly if a connection cannot be made with its target. On Windows, the Angle CMake deployment and the desktop deployment will now build with multiple threads by default. We also fixed a couple of bugs with various licensing edge cases. We've also made several improvements to GLS packages and the package system. For improvements, the GUI test framework package now highlights pixel differences in test results in white so that differences are easier to see. Over here on the right, we can see this change to the GUI test framework package. So when you're looking at test results, you can hover over these failed tests to see the pixel differences highlighted in white. So there the GIF's going, and you can see it fade in and out to the white pixel differences. So this feature can help you identify why a certain GUI test is failing and give you an indication of what to fix. Going back to some other improvements, package references now have an option to fall back to use the latest available version of a package if the exact version specified is not found. Additionally, we've added the ability to force square textures to our texture atlasing package, which can be useful when trying to use hardware compressed textures. This is relevant for embedded systems development, where memory usage can be a concern. We've also fixed lots of package bugs in this release. Several fixes have been made to package dialog options that could cause the editor to feel unresponsive. Additionally, we've fixed a bug with the GUI test framework package, which would cause the test driver to get stuck and prevent the package from working correctly. Again, this is just a small subset of the changes we've made to packages for this release. We've made enhancements to many aspects of the editor and runtime for this release. We've tried to improve the experience while using the editor in general, and we've made some ES-specific improvements to the runtime. The code editor used to give a rather small and cramped space to edit code when working with GeoStudio properties, so we've added the ability to resize those elements of the code editor easily. On the right, we can see a GIF showing the new resizing options available in the code editor. You can see that while editing these properties, you can hide, show, and dynamically resize these setter and getter tabs. Another improvement is that we've added a way for users to easily remove unused textures from their design. In GLS 8.4, we've updated our ES runtime to include all image formats that are supported in our desktop runtime. This means that you will be now able to use PSD and DDS files as textures in your ES projects. In previous versions of GLS, a shader that failed to compile in a built application would cause the application to exit. Now, a failed compilation of a shader will attempt to use a minimal shader. This minimal shader will simply show as magenta, similar to how a missing texture looks like in GeoStudio. The last point here for improvements is that ES generation now allows components to be located in subfolders of layout in GeoStudio projects. We have a couple of bug fixes that are particularly relevant for ES. A few different bugs were fixed which caused the GeoStudio editor to incorrectly report texture information as well as polygon and vertex count. This information is now reported correctly. And lastly, for bugs fixes, a bug was fixed where ES applications would ignore the perspective projection setting in application settings. ES applications will now use the correct projection. So GeoStudio already has some built-in functionality to open our Doxygen API documentation while inside the editor. This release, we've been adding some improvements to make this experience even better. In GeoStudio, pressing Ctrl plus F1 in the editor will bring up our hosted documentation, which can be found at doxygen.disty.com. Pressing F1 will bring up the user manual documentation. If you select an item in the geometry view of GeoStudio, pressing Ctrl F1 will open up documentation specific to that object's class. What's new is that if you don't have an internet connection, GeoStudio will bring up the offline version of these documents. You can see on the right side of the screen that the documentation being viewed is from a local file. Up here in the URL, this is showing a local file. So starting in GLS 8.4, copies of the Doxygen documentation will be bundled with the GeoStudio installer. You won't need to separately download the offline documentation. So moving on to our next feature, we're going to explore the new cross-platform video integration. So GeoStudio now supports cross-platform video integration with two new packages. The GLS multimedia package provides easy-to-use behaviors that allow a user to stream video and audio content in GLS applications. The GStreamer video server package, which makes use of the open-source GStreamer framework, powers the functionality of GLS multimedia. The behaviors from GLS multimedia that you can use in the editor are video polygon and audio source. These behaviors will allow you to stream content over the network or from local files on the same machine. Additionally, these behaviors support seeking, variable playback speed, and pausing. Both packages are initially supported for the desktop CMake deployment on Windows, Mac OS, and Linux. They're also supported for the embedded CMake deployment for embedded Linux, specifically Octo, and the Raspberry Pi CMake deployment for Raspberry Pi OS. The main behavior that you'll be using for cross-platform video integration is the video polygon behavior. To actually render and play video content in a GeoStudio application, you'll want to attach this behavior to a rectangle GeoPolygon in your design. On the left here, you can see a view of the custom properties for video polygon. You can configure stream location, video width, video height, transparency, and enable looping, sound, as well as set the stream volume. At runtime, there is additional functionality in the API to allow you to pause the stream, seek in the stream, and set the playback speed for the stream. If you're only interested in playing audio and not video, we've created an audio source behavior. To use it in your designs, you can attach the audio source behavior to an empty group and and use its properties and functions in a similar manner to how you'd use Video Polygon. You may be wondering how the cross-platform video integration works under the hood. The good news is that it lives in package space. This means that you can not only see how the implementation works, but you can customize it as well, as all the source will be available to you. One area of customization that you may want to look into is customizing the GStreamer pipeline used by the GStreamer video server package. When using cross-platform video on GL Studio ES, the default pipeline is set up to accelerate streaming of H.264 video, which are basically MP4 files, on the NXP IMX8. However, you can customize this pipeline. In particular, there's a rebuild pipeline function that you can modify in order to use GStreamer plugins that are available for your hardware and board support packages. Another thing to note is that under the hood, the video server and your GLS application will run as separate processes. This means that your application does not need to directly link with LGPL or GPL dependencies while still being able to leverage the powerful GStreamer framework. Additionally, custom video servers can be used, but the video server provided by GStreamer Video Server is used by default by GLS Multimedia. As long as the video server you're using is able to communicate appropriately over the shared memory interface that the GLS Multimedia behaviors use, it can be substituted for the GStreamer Video Server. In that case, GStreamer would not be strictly required. One note here is that for platforms such as Android or iOS, in which GLS Multimedia is not yet supported, media can still be played alongside GLS content by using one of the platform's media APIs. There's an example of how to do this on Android on our documentation site. Now I'm going to show a demo of a simple application that shows a cockpit flight video on Windows, Linux, and Raspberry Pi. So I'm on Windows at the moment. I am in the editor, and this is my cross-platform example project. First thing that we're going to look at here is this polygon in the center of the design. If you look here in the geometry tab, you'll see that this has a video polygon type behavior attached to it. If I scroll down to here, you'll see that there are custom video control properties that have been set. So for my video, I've enabled looping. I've got my stream location set to this cockpit flight video. I've made it fully opaque, and I've configured the resolution that the video should show. Something else to point out here is that I have a transparency slider that'll control the transparency of the video at runtime, as well as a video progress bar shown across the bottom of the screen. So if I go ahead and click run, we'll see this project build, and I have to drag it over to the screen. So here you'll see the project running. You can see that the video is being streamed to this polygon. We've added an animation that allows the polygon to be moved around in 3D space. After all, this is just a polygon, so you can transform it in any way that you'd like a polygon to be transformed. And I can use this transparency slider to change the transparency property at runtime. Also note the video progress bar increasing. Secondly, on this Linux machine, so this is a Linux virtual machine running GL Studio. This is the exact same project with no modifications. I can go down here and show the video control properties. You'll see that the properties are set the same way here, and everything else is the same. So if I click run, you'll see that the video immediately pops up and it runs and animates just the same way it did on Windows. The progress bar is also working, and the transparency works just the same. So for Raspberry Pi, I'm going to be showing a pre-recorded demo. So we're here on a Windows host, and we're using the Raspberry Pi CMake deployment. You'll note that this project is the exact same project that I used in Windows and Linux earlier. So I'm clicking the build and deploy buttons on the deployment toolbar to get it onto the Pi. When I click the run button, the app immediately launches on the Pi. I'm moving the transparency slider, and the functionality is just the same as it is on desktop Windows and Linux. And I'm going to let this play so that you could see some of the video. Go. All right. In addition to the big new features we discussed, there are numerous improvements and bug fixes included with GLStudio 8.4. While I won't go over every one of these right now, I would like to highlight that many of these are quality of life improvements for the GLStudio editor. Be sure to check out the 8.4 changelog at our docs.dist site for the full list of new features, improvements, and bug fixes. So this concludes our look at the new features introduced with GLStudio 8.4, which was launched in November 2025. To reiterate some of the key features, we have cybersecurity testing and reports, the automatic polygon optimizer package, out-of-the-box experience enhancements, cross-platform video integration, and many bug fixes, package updates, and more. So go ahead and download your copy of GLStudio 8.4 today.
Thanks, Jeya. And with that, we'll go ahead and go to our Q&A section. So if you have any questions, feel free now to leave them in the chat. It looks like we have several good questions already, so we'll go ahead and start going through those. So first question is, will cybersecurity integration into 8.4 affect runtime performance? And the answer to that is no. There should not be any effect for runtime performance. Another question, can you undo a polygon optimization while developing, such as return your GLStudio polygon back to a simple rectangle if anything goes wrong? So the optimization does save in the undo history. So while you're actively developing, if you do the optimization but then want to go back, you can undo it. Now, if you save your project and close GLStudio and reopen, you're not going to still have that undo history. So if you are concerned about that, there's a couple options. I guess the first one would be you could make a duplicate of the original object and just set it to invisible so it doesn't get drawn. And that way, if at any point you don't want to use the optimized one anymore, you still have that backup. So that would be one option. Also, you could simply re-import the original texture and it will create a rectangular polygon with the texture applied. But I think the undo history will probably be suitable for most circumstances. Next question we have is, will running the polygon optimizer result in a higher number of polygons and vertices? And the answer is yes, because you're starting with a rectangle polygon and then converting that into a grouping of, or a mesh of triangle polygons. So you will have more polygons and vertices, but the important thing is that drawing fill is significantly more demanding than the number of polygons and vertices itself. So you're still going to see a great runtime performance improvement since we're reducing that area that gets drawn. Next question we have, does GLStudio require OpenGL, or are there other options for embedded systems with no GPU, say for a microcontroller or a RAD-tolerant CPU? The answer is yes. We do have what we call GLStudio Micro that can be ported to microcontrollers. So if that's something you're really interested in, you can reach out to our sales team and we can talk about that further. Similar thing with RAD-tolerant CPUs. We do have a way to render GLStudio content without GPUs. And if you'd like to learn more about that, again, you can reach out to a DISTI sales representative for more info. So You can email sales@disty.com if you would like to get in contact. Next question, how long does it take for GL Studio to port to a new embedded target? What does that porting process look like? So the answer to this depends entirely on what the target is. We have performed, I want to say, close to 100 different ports before, so we do have many existing ports already. Going to a new target, it could take anywhere from a couple days to over a week. Just depends. And the process for that is that the GL Studio team will need to port our embedded system runtime for that new target, and then we'll provide that ported runtime to the customer so that they can build their project against it for the target. So if you want to learn more about that, reach out to our support team, support@disty.com. Someone asks, when is the new version of GL Studio available and how do I get access to an evaluation copy? So the new version is available for download today on our docs site, docs.disty.com. If you're interested in an evaluation copy, reach out to our sales team. You can email sales@disty.com, and they'll be sure to help get the process going to get a free evaluation going. Next question is, will the RSO integration package to Unity 6 on macOS using AngleES be available with 8.4 when it ships? We currently use it in 8.2. And so the answer is that it should work as is, since it is RSO loader based. But if it seems like you're having some issues with using it on the new version, please reach out to our support team and we'll be happy to help work that through with you. Next question is, does the GStreamer video integration only work on desktop OpenGL, or will it also work on embedded systems like an NXP IMX95 running QNX or Yocto? Jeya, maybe you'd
Yep,
be
I
happy to
can
answer
take this
one.
one. So the cross-platform video integration works on desktop and ES. So out of the box, there's no, the ES support is built for Yocto running on an IMX8. That's going to be really similar to NXP's IMX95 running Yocto. So it would probably work out of the box on the IMX 95. One thing to note, though, is that for QNX, there would be a little bit of work to get it working. There are no specific like Linux system calls being used for our cross-platform video integration. And QNX does support all of the POSIX shared memory operations that the integration depends on. So it's very feasible that support for QNX could be added relatively easily. You could probably honestly do it yourself since it is in package space. But yeah, you could reach out to Disty and see if we could support QNX for your use case.
Cool, thanks for that. I'm not seeing any new questions in the chat, but I'll give it a little bit longer here in case anybody has some that they just thought of. I think there is a slight delay here, so I'll just wait another 15 seconds or so and see if there's any new questions. I'm not seeing any new questions, so I guess we can go ahead and wrap it up here. I want to thank everybody for taking the time to watch our presentation. We hope that you found it informative, and remember to download GL Studio 8.4 today from docs.disty.com. we're excited for you to get your hands on it. Thanks, everyone. Have a good day.
Yep. Thank you, everybody.